Welcome to Connected World, a podcast created for engineers to learn about the latest technology trends, creating a safer, sustainable, productive, and connected future. Hello, everyone, and welcome to Connected World, a podcast from the experts at TE Connectivity. I'm your host, Tyler Kern, and today we're talking about urban air mobility power distribution with Bruce Conway. He's the principal scientist for AD&M wire development at TE Connectivity. Bruce, welcome to the show. Thanks for joining me.
Oh, very good to be here.
Excellent. Well, I'm excited to talk to you today, Bruce, and I think it would be a good idea just as we get started to give everyone a sense of your background, a little bit of your history, and also your role at TE Connectivity. What does it mean to be the principal scientist there for wire development? So just kind of tell us a little bit more about yourself.
Well, I'm actually a second-generation Silicon Valley engineer. Background's applied physics. I've worked in advanced development most of my career, an awful lot of it with TE and originally with Raychem. Worked my way up through advanced development for the last 20 years or so. I'm now with the Wire Development Group, and the reason wound up over here is that a lot of my interests have to do with energy and space, and we make a lot of inroads into both of those here.
Excellent stuff. Excellent stuff. So today we want to talk a little bit more about some of the power needs for eVTOL vehicles, over traditional aerospace design. So what are some of those unique power needs that an eVTOL has that maybe other traditional aerospace designs don't have or don't need?
Well, in the traditional designs, you have a generation plant and a power bus, and you're simply hanging devices off of that. Everything's just a consumer from that. The main power is being produced by the engines and is consumed by the engines. In the case of eVTOL, you have a battery plant, and you have the distribution of the battery plant either through converters or directly to the lift engines. Now, those lift engines can be in a variety of different architectures, everything from something linearly fed or something that requires a network for doing current and power sharing. That's very great departure from traditional architectures. Also, generally with traditional systems, you're simply running power one direction. With eVTOLs, you also have a charge path, and that charge path can be very challenging.
So given those unique power needs that you were discussing and the fact that you work in wire development, tell me a little bit more about how this creates challenges when it comes to power cabling. What does that look like for you?
The biggest issue with it is eVTOLs, every kilogram counts. You have a battery plant, and the battery plant is really the enabling technology here. They come in with batteries at a little over 1 megajoule per kilogram, which is the specific energy. That's really the threshold for electric flight. So every single joule of energy is important. You need to be able to get it from the battery to the pods, the engines, very efficiently. Also, eVTOLs tend to be very light and very small. You have a great deal of problems with routing, with power density, with ohmic losses. And there's a number of ways you can go ahead and compensate for that, including raising voltage, non-traditional geometries, and again, like I said, networks rather than linear feeding.
So how complex do these cables end up being once they're completed? Once you've kind of completed all of it, the various aspects and compensated for all of the challenges that are required to be taken into account for eVTOLs, how complex are these cables?
When you start talking about cables or wire, people look at it and they just see a wire. When it's finished, it looks simple. But the reality is that for a lot of cables, because of the very unique requirements, such as everything from corona inception to high temperature, they all require very unique developments in materials. The Raychem pedigree we have with TE has addressed that. We literally have things that have left the solar system even. So it has a lot of unique problems just in the design. Now, that being said, that's traditional round wire. One of the things with eVTOLs that's very important is cross-section. We're looking at a lot of varied geometries as well, going outside traditional wire. So be it either individual large gauge equivalent flat densified cables to one of our products called the TU that's actually been around for quite some time, being reapplied to eVTOLs. that's a flat power carrying ribbon cable, complete with its own connector system. So you really, for eVTOLs, you have to think outside the box for flexibility, for size, for cross-section, not just overall size. And then, of course, there's also the weight aspect, which is every ounce counts.
Yeah, and that kind of takes me exactly where I wanted to go, and that was talking about size, weight, and power. So you've brought this up a couple of different times now, just talking about eVTOLs tend to be light and smaller and that sort of thing. So how does urban air mobility take this idea of size, weight, and power and kind of these things, I guess, combine to make for an interesting challenge that takes things to the next level?
Well, that acronym also, SWAP, size, weight, and power, is very common in the aerospace industry. The large airframe manufacturers are concerned with it as well. About every kilogram of weight you take off a medium to large size airframe, you save up to $750 for the lifetime of the airplane on fuel. So they're very concerned with it as well. But eVTOL, again, every joule counts. If you waste energy, rather than 20 minutes in the air, you may get 5. So we need to look at the size of it for being able to do the routing. Every kilogram we shave off of it means greater lift and longer flight time. And then power, being able to handle power in a smaller conductor. And again, that's two ways. And this is the big one, that when you're charging these systems, that pathway may have to carry as much as 8 times the current that you would for the discharge. And it's brought up things like doing direct battery connections for the charge cables, and we do have some options for that are being worked on. That way you don't have to carry the charge cable aloft. Or if you do, being able to do it with a new type of flexible bus bar that maximizes the current carrying capability while still keeping the weight under control. I mean, there's really one more word to that acronym we've kind of added on, and that's flexibility. eVTOLs, if there's two basic designs. I mean, you have the one that's sort of a pseudo helicopter with multiple pods all arranged together overhead fixed. You have also then a lot of ones with rotating pods / rotating wings. So many times we have to look at cables that actually can be flexed or rotated. That we call that dynamic bending. Static bending, we have our cables designed for that for a lot of the airframe manufacturers, but dynamic bending is a whole other animal. And we have seen an awful lot of that being required. And in small spaces, so your surface loops are not that big for doing the bends.
That's really interesting. Yeah, that does present just interesting challenges and interesting conversations that I would think to be had. So when I think about this, I think this is all extremely exciting. But what excites you for the future? And as someone that works in this day in, day out, and you're seeing the development of these things, how excited are you? And what particular things kind of get you going and excite you about the future of eVTOL?
Well, to begin with, I'm of that age range. I was brought up on cartoons like the Jetsons. So always watching the flying car in the opening sequence. Everybody wants one of those. And the idea of small personal aircraft, I've seen estimates of that or inroads into that all my life. Even things from the 1930s, watching gyrocopters and everything that were being developed back then. To me, it's just a very interesting, exciting thing for the 21st century that we're actually approaching this point where this isn't science fiction anymore. This is actual reality. There are these companies that are realistically going to be having air taxis in the next 4 to 5 years. Some would argue sooner. And it's a once in a lifetime career opportunity to be involved in an industry like this. You get to take something like wire, which is a reasonably static thing, and you have to reinvent it. I mean, we're talking about the geometry and insulation chemistry. But there's also, for the long run, things like CNT, which is carbon nanotube. If that technology matures, it'll change virtually everything. It'd be very exciting to be around when that happens. You can have a 24 gauge wire that could carry the same current as a quadruple aught if that technology is perfected. So that'll change the whole game. To me, it's just seeing this technology finally starting to become reality rather than science fiction.
Yeah, I know you held an internal symposium with some folks from TE Connectivity to really kind of share the fact that this is becoming a reality. What was the reaction to that? Are there still people that maybe aren't aware of maybe how close this is to really becoming a thing that we see on a regular basis?
Well, the whole reason for the symposium was internally at TE, we have huge engineering community in TE. TE is about 57,000 employees. But we're all in different divisions. And this, we once a year host a internal conference for technology. And this was a wondrous opportunity to be able to talk to everybody from all the different divisions. And trying to get the point across, this isn't science fiction anymore. This is real. And it was wildly successful. It really did start our effort internally to do this development, bringing in everything from our terrestrial power, our rail group, from automotive, which has already done huge amounts of work for electric vehicles. It was definite consensus builder, and that and giving everybody a small UAM to take home really helped.
What are some of the major developments that you see coming down the road then that you think, okay, if this is going to be something we see regularly in 4 or 5 years, what sorts of things do you think are the next hurdles that will be cleared in the roadway to making this a reality?
From the wiring point of view, our big thing is being able to go up in power density, lower weight, and also go up in frequency. There's some real need to be able to drive the motors directly with, multi-kilohertz power cables. So that's a distinct possibility. I mean, overall, for this industry to really, the next true hurdle is the battery plant. I mean, the frequency converters, the distribution networks, the lift engines are all maturing reasonably quickly. The battery plant, as I said, is at that specific energy of around 1 megajoule per kilogram. When that hits 2 to 3 megajoules per kilogram, you will see this really start to take off, and also you'll start seeing it evolve into electrically assisted flight for regional aircraft. If it hits 10 megajoules, 15 megajoules per kilogram, you will see it displacing traditional fossil fuel driven aircraft. So it's going to be an exciting thing, but that's the big hurdle, the being able to carry enough energy aloft to be able to power flight for a reasonable amount of time with enough lift capacity.
Well, it's certainly an exciting time, Bruce, and I can't wait to continue to see what work you find folks and brilliant minds at TE Connectivity continue to do to make this all possible for us. And so it's an exciting time, Bruce. Thank you so much for joining us here on the podcast. Do you have any final thoughts or conclusions or anything that you'd like to leave our audience with today as we begin to wrap up this episode?
Well, I do want to invite them to definitely contact us with any needs they have, and if you want to. We have a interactive tool that's even available that shows how to configure your architectures. And if you want to check that out on our website at www.te.com/urban-air-mobility, please do so. Also, feel free to look me up on LinkedIn if you wish to contact me directly, and I'll be more than happy to either answer your questions or direct you to the appropriate party.
There you go. Fantastic stuff there from Bruce Conway, Principal Scientist at AD&M Wire Development at TE Connectivity. Bruce, thank you again so much for joining us here on the podcast and sharing some amazing insight with us.
Well, thank you very much for having me.
And everyone, you heard Bruce. You can reach out to him and you can visit the website that he listed as well to get more information, to learn more about everything that TE Connectivity is doing in this world. And stay tuned for more episodes as we continue to talk about urban air mobility here on the podcast and continue to dive into some of these really exciting topics. You don't want to miss a single episode, so make sure you subscribe on Apple Podcasts or Spotify or wherever you get your podcasts these days to stay up to date with the latest from the fine folks at TE Connectivity. And stay tuned. We'll be back soon with new episodes of the podcast. But for this one today, from my guest, Bruce Conway, I've been your host, Tyler Kern. Thank you so much for joining us.